So differentiating with the chain rule allows us to look at a function that's a function within a function and differentiate it without having to expand anything out. And we do this by introducing this new variable v. So the function that's within the other function, so for instance if we had f of g of x, we set g of x as our new variable v, and then this allows us, just by a simple multiplication at the end, to differentiate this whole expression without having to find a sort of expanded version of it. So the only important thing to remember is that once you've introduced this new v and you've highlighted what this function variable v is, that it's a multiplication at the end. So here's a question then. Y equals 3x squared plus 6x all to the power of 7. So if we introduce this new variable, we can say that we've got y equals v to the 7, where v is 3x squared plus 6x. So our function y is now in terms of v, and our function v is now in terms of x. So when we differentiate y, we're going to differentiate it in terms of v, and that's 7v to the 6. And when we differentiate v, we're in terms of x, so we're going to get 6x plus 6. Now we know from the previous slide that dy by dx is dy by dv multiplied by dv by dx. So dy by dv we know is 7v to the 6, and we're multiplying this by 6x plus 6, which is our dv by dx. Now, we're talking about dy by dx here, so actually we don't want to see this v here anymore. But we know what v is, we established that. V is 3x squared plus 6x. So now we can replace that as well. So we've got 3x squared plus 6x to the power of 6 times 6x plus 6. And all we need to do now is tidy that up. So I'm going to move up here for a minute, and that is going to be, well, I'm going to factor out the 6 on this second bracket here and times it by the 7, so that's 42. I'm left with an x plus 1, and then 3x squared plus 6x to the power of 6. And that's it, that's differentiating using the chain rule.